Well, hello everyone. I got the notice. All right, in this presentation, I'm going to be discussing assignment evaluation order. I will discuss why assignment evaluation order was inconsistent in older versions of Ruby and how we fixed it in Ruby 3.1 and 3.2. My name is Jeremy Evans. I'm a Ruby committer who focuses on fixing bugs in Ruby. I'm also the author of Polished Ruby Programming, which was published last year. This book is aimed at intermediate Ruby programmers and focuses on teaching the principles of Ruby programming, as well as trade-offs to consider when making implementation decisions. So first, what is assignment evaluation order? It's not something that most Ruby programmers need to think about, but all assignment expressions have an order in which the expression is evaluated. So here's a simple assignment example. We start off defining a method named A that returns an array, and we have a method named B that returns 1, and then we get to this assignment expression where we can consider the assignment evaluation order. So how is this assignment expression evaluated? Well, note that there are 3 separate method calls in this assignment. There's a method called A, which will return the array. There's a method called B, which will return 1, and then there's a call to the element assignment method. Now it is clear that this method must be called last because it's called on the result of A with the arguments of 0 and the result of B. However, it is probably not obvious which of these 2 methods is called first, A or B. Now in this case, Ruby calls A first, then B. So the assignment evaluation order is A, then B, then the element assignment method. Now, the reason that A is evaluated before B is that Ruby follows the left to right evaluation principle, in that a typical expression will evaluate the left part before the right part. You can see the left to right evaluation principle in other cases in Ruby. So consider this code with the same definitions of A and B. So how does Ruby evaluate this expression? Well, with the left to right evaluation principle, P comes first. But Ruby cannot evaluate the P method call yet because the results of A and B are arguments. So it continues. Ruby comes to A next, so it first evaluates A, then it comes to B next, so Ruby then evaluates B, and now that it has the results of the method calls to A and B, it can then evaluate the method call to P. So more precisely, the left to right evaluation principle in Ruby is that Ruby will evaluate expressions in a left to right order, delaying the evaluation of the current expression if it depends on expressions to the right until all expressions it depends on have been evaluated. Now, unfortunately, this principle of left to right evaluation was not implemented consistently in older versions of Ruby. So here is a case where older versions of Ruby did not follow the left to right evaluation principle. So we have the same method definitions of A and B as before. Now in this case, the assignment expression uses multiple assignment. Now following the principle of left to right evaluation, you would assume that Ruby would first evaluate this call to A, and then this call to A, and then this call to B, and then this call to B, and then the first element assignment, and then the second element assignment. However, that is not what happens. Ruby before 3.1 violated the left to right evaluation principle. First it evaluated the left call to B, and then the right call to B, and then the left call to A, and then the left element assignment, and then the right call to A, and then the right element assignment. So this evaluation order issue for multiple assignment was known for a long time. It was reported and confirmed as a bug before the release of Ruby 1.9.3, reported by Endosan. Before it was fixed, this issue was one of the oldest still open bugs in Ruby's bug tracker, with over 10 years between when it was reported and when it was fixed. Now this bug was reported in Japanese. I don't speak Japanese, so I had to rely on a Google translation of the bug report and the initial discussion. But apparently, from the translation, the bug was considered difficult to fix by Mats. And Mats was not wrong. Of all the bugs I've fixed in Ruby, this was the most challenging bug to fix, and it took far more time to fix than any of the other bugs I have worked on. So while not directly related to the multiple assignment order evaluation issue, there was a similar evaluation order issue for constant assignment. So here's an example of that. The code is similar to before, except that the A method returns a module. So here we have the assignment. And the left to right evaluation principle indicates that we should first evaluate the A method, and then evaluate the B method, and then set the constant on the result of the A method. But what older versions of Ruby do is evaluate B, then evaluate A, and then set the constant on the result of the A method. So this constant assignment evaluation order issue was published in reported in 2019. I ended up fixing this issue shortly after fixing multiple assignment, and thanks to the work I did on fixing multiple assignment, it was much easier to fix constant assignment. So the fix for constant assignment evaluation order was not merged into Ruby until after Ruby 3.1 was released. So Ruby's assignment evaluation order will not be fully consistent until the release of Ruby 3.2. So I'm first going to discuss the issues related to multiple assignment evaluation order, since that's the more complex and challenging case. So it's probably not obvious at first glance why fixing multiple assignment evaluation order would be so challenging. I mean, after all, it appears you're just changing the order in which you're doing the evaluation. And surely, going in, this is as simple as moving code from one section to another, and what could possibly be so hard about that? Well, unfortunately, it's not so simple as it would first appear. And one of the reasons for this is that Ruby uses a stack-based virtual machine. So Ruby compiles your source code into instructions that are executed on this virtual machine. And most of the implementation complexity for left-to-right evaluation comes from having to correctly manage the virtual machine stack. So what do these virtual machine instructions look like? Well, Ruby comes with tools that allow you to easily see the generated instructions. You can run your Ruby program with the dump option with an argument value of I, which is short for dumping instructions. And this will allow us to see how multiple assignment instructions changed between Ruby 3.0 and Ruby 3.1. So we're going to start with a slightly different example. So here we have a multiple assignment expression, which will set the B attribute on A, and will set the first element of C with the values of D and E. When you run Ruby 3.0 with the option to dump instructions, you get these instructions output. As Ruby uses a stack-based virtual machine, in order to understand how these virtual machine instructions work, you also need to consider the virtual machine stack. So here's where we're going to show the stack. Now currently, the stack is empty. So as I mentioned earlier, Ruby 3.0 evaluates the right-hand side of the assignment first. And the first expression in the right-hand side of the assignment is the method called a D, which is implemented using these two instructions. So the first instruction, put self, adds self to the stack. Self will be the receiver of the D method. We're going to use a right arrow to show objects added to the stack by the current instruction. The next instruction is opt send without block, which is an optimized instruction that's used for certain method calls. From looking at the data associated with this instruction, we can see that it is calling the D method with 0 arguments. Since the method call passes 0 arguments, the virtual machine pops the top entry in the stack, which is the receiver of the method. And it pushes the result of the method, which we're going to call D. So we're going to use a left arrow to show objects removed from the stack by the current instruction. So you can see that this instruction removes self from the stack and replaces it with D. Next, Ruby 3.0 has to evaluate the method called E. And this is the same put self and opt send without block instruction. So this pushes self on the stack and it pops it off the stack when calling the method. And then it pushes the result of the E method onto the stack. Now it's probably not obvious why we have these next 3 instructions. So the reason for these instructions is that this multiple assignment expression is the last expression being evaluated. So the return value of the multiple assignment expression is needed. And that's going to be the array containing the right-hand side of the assignment, the results of D and E. So the first instruction, new array, has a value of 2, which tells the virtual machine to pop the top 2 entries in the stack and push an array containing those 2 entries. The next instruction, dupe, takes the top entry on the stack and pushes it onto the stack. So the top 2 entries in the stack will always be the same after a dupe instruction. The next instruction, expand array, pops the top entry in the stack, which should be an array. In this case, it is given the arguments of 2 and 0, and those arguments mean it should push the first 2 elements into the array onto the stack in reverse order. So it pushes E, and then it pushes D, and D is at the top of the stack. So now the stack contains D, E, and then the array of D and E in that order. Now Ruby is going to evaluate the method called A, and this is just like the method calls to D and E, and the result of A gets pushed onto the stack. Now the next 4 instructions implement the B equals method call. So the top N instruction is used to push an existing stack entry onto the stack. And the argument it is given is the offset from the top of the stack. So the argument value of 1 in this case means to push the second entry into the stack onto the stack. Now the next instruction is another send instruction, but unlike the previous send instructions, this send instruction takes 1 argument instead of 0 arguments. So that means the virtual machine, instead of popping 1 entry from the stack, is going to pop 2 entries from the stack. So the top entry in the stack is going to be the argument to the method, and the second from the top is the receiver of the method. So this calls the B equals method on A with the value returned by D, and it pushes the result of the B equals method onto the stack. Now the next 2 instructions are both pop instructions, each of which removes the top entry in the stack. We don't need the value of the B equals method, and we no longer need the value of the D method, so those are both popped from the stack. Next, Ruby needs to evaluate the method called a C, and this is just like D, E, and A, and the result of C gets pushed onto the stack. Now finally, we get to the element assignment method call, setting the first element in C. So the first instruction here is put object intofix 0, which pushes the number 0 onto the stack. This is the first argument to the element assignment method. The next instruction is top N with an argument of 2, which means push the third entry in the stack to the top of the stack. This is going to be the second argument to the element assignment method. Now the next instruction is opt aset, which is an optimized instruction used for the element assignment method. This method call takes 2 arguments, so it's going to pop 3 entries from the stack. The top 2 entries in the stack are arguments to the method, and the third entry in the stack is the receiver of the method. So the result of calling this method is then going to be pushed onto the stack. Now the next 2 instructions are again both pop instructions. We don't need the value of the element assignment method or the return value of the E method anymore. And the final instruction is leave. This is used for return values. So since this is the last expression being evaluated, the top entry on the stack is popped as the return value. Now in this case, the return value is the array containing D and E, because that's the right-hand side of the assignment. So that is how multiple assignment was implemented in Ruby 3.0. I think you really get an appreciation for how much Ruby does for you when you start going through each instruction. Now here are the instructions when using Ruby 3.1. And first, you can see right away there are more instructions. Some of the instructions are the same, but instructions have been reordered, and there are more instructions that deal with stack manipulation. So in Ruby 3.0, this code resulted in 6 stack management instructions, such as dupe, pop, and top N. On Ruby 3.1, there's 13 stack management instructions. And as you might expect, due to this, multiple assignment with attribute and element assignment is slightly slower in Ruby 3.1 than in 3.0 due to this, such as the cost of correctness. So you now have some experience interpreting these instructions, we can pick up the pace a bit. So as I discussed, Ruby 3.1 uses the left to right evaluation principle for multiple assignment. So it first evaluates the call to A and pushes the return value on the stack, and then it evaluates the call to C and then pushes that return value on the stack. And then before it evaluates the right-hand side of the assignment, it evaluates the first argument to the element assignment method. If this argument to the element assignment method was a method call, that method call would be evaluated before evaluating the right-hand side of the assignment. So next, Ruby evaluates the D and E method calls and pushes the results of those onto the stack. Ruby uses the same new array, dupe, and expand array instructions when the result of the multiple assignment is needed. And it pushes, so just as before, this pushes an array containing D and E onto the stack, and it results in D and E switching places on the stack because D will be used first. All right, so now we get to the instructions that Ruby will use to implement the B equals method call. We're going to take this section instruction by instruction. So the B equals method call is called on the result of A. So we need to push the result of A to the top of the stack. Now that's done via a top N instruction with an argument of 5, since A is 6th place currently in the stack. Next we have a swap instruction, which swaps the top 2 stack entries. And that's because the following instruction is a method call taking 1 argument. So we want to have the receiver of the method second from the top and the argument to the method on the top. And then we have the method called the b equals method that pops the top two entries on the stack, and it pushes the return value of the b equals method onto the stack. Now we don't need the return value of the b equals method, so we immediately pop that from the stack. Now Ruby needs to evaluate the element assignment, which it does using these instructions. So again, we'll go through this section an instruction at a time. So first it uses a top-end instruction with an argument of 3 to push the receiver of the element assignment method, C, onto the stack. And next it uses the same top-end instruction with an argument of 3 to push the first argument of the element assignment method onto the stack. So even though top-end uses the same argument in this case, it pushes a different stack value because the argument to top-end is the offset from the top of the stack, and the previous instruction pushed an entry onto the stack. So now we have another top-end instruction. This one uses an argument of 2. This is pushing the second argument of the element assignment method onto the stack. The following instruction is the element assignment method, calling that with 2 arguments. So that's going to pop the top 2 arguments and the receiver from the stack, and it's going to push the return value of the element assignment method onto the stack. So that return value is not needed, so that's popped from the stack, and the return value of E is no longer needed, so that's also popped from the stack. Now the next instruction we haven't seen before. This is setN. So the setN instruction replaces the stack position at the given offset from the top of the stack with the value that is currently at the top of the stack. So in this case with offset 3, we were replacing the bottom stack entry with the top stack entry. And the reason we're doing this is that we want to return the value as the result of the multiple assignment expression. We want to return the right-hand side of the assignment. So we no longer need the top 3 stack entries, so we pop each of those, and then we return the value of the multiple assignment expression, the array containing D and E. And while it is more complex than the Ruby 3.0 code, the Ruby 3.1 instructions correctly implement the left-to-right evaluation principle. Now the challenging part is using the correct stack management instructions, mostly in keeping track of what offsets to use for the top-end instructions. And as you can see here, I mean, at least in the simple case, it's not actually that complex. So why was it so challenging to implement this? Well, in order to show you why it was challenging to implement, we're going to look at differences in instructions when we make just small modifications to the code. So we'll start with the example code we're using, and let's say, here we're going to show the Ruby 3.0 and 3.1 instructions side by side. And to make sure everything fits in the screen and to more easily show the differences, we'll condense the instruction display slightly. So what happens to these instructions when you add an argument to the element assignment method? Well, here are the new instructions. And since it's not obvious what's changed, let's look at a diff between those 2 instructions. So we can first look at the instruction differences in Ruby 3.0. So one instruction was added, put object into fix 1, which pushes the integer 1 onto the stack. The following top-end instruction, argument value, changes from 2 to 3, and the opt aset instruction changes to opt send without block, with an argument value switching from 2 to 3. All the changes are localized, and all other instructions remain the same. So let's compare the Ruby 3.0 changes to the Ruby 3.1 changes. And it's a different situation in Ruby 3.1. That addition of a single argument affects many instructions, with all of the offset arguments getting modified, and with the addition of additional top-end and a pop instruction. So we can tell from this that the offsets to each instruction are based on the number of arguments in each element assignment method on the left-hand side. Well, instead of adding an argument to the element assignment method, let's see what happens if you make the multiple assignment set an additional local variable at the end. On the Ruby 3.0 side, the argument to the expand array instruction goes from 2 to 3, and there's an additional instruction to set a local variable. All other instructions remain the same. Well, on the Ruby 3.1 side, you get those same changes to expand array and the instruction to set the local variable. However, 3 of the top-end instructions now have shifted offsets. Some of the offsets shift, but not all of the offsets. So you can tell from this that the offsets are not just based on the number of element assignment method arguments, but also on the total number of attributes, elements, and local variables that are being set in this multiple assignment. Now what happens if you add the local variable to the beginning instead of the end? Well, the interesting thing here is the instruction change is the same in both cases. And you can infer from this that the offset changes depend on the position of the attribute assignments relative to the local variable assignments. And you can confirm this by adding the local variable to the middle In this case, only the first top n offset needs to be changed, not the other offsets. Otherwise, the instruction differences are the same between versions. What if instead of adding a local variable, we replace the element assignment with a local variable? Now we can see that this significantly reduces the number of instructions, but what changes? So in Ruby 3.0, this results in a bunch of instructions being removed and a single instruction being added to set the local variable. On Ruby 3.1, this also results in instructions changing, but it also requires changing the initial top n offset and the set n offset. So this shows that the offsets depend not just on the number of assignments, number of arguments, and position of the assignments, but also the types of assignments that you're doing. Now, unfortunately, multiple assignment in Ruby is more complex than just setting attributes, elements, and local variables. You also need to deal with splats. So we're going to see what the differences are if we splat the second expression being evaluated. Now, it turns out that using a splat does not change the offsets. The instruction change here is the same in both cases, modifying the arguments to the expand array instruction. All right. Now, if the splat is on the first argument instead of the last, and you're setting post-splat attributes, there are also a few differences. So instead of just changing the arguments to the expand array instruction, an additional expand array instruction is used. But that's the only instruction change, and it's the same in both Ruby versions. So this gives you the impression that splats don't actually add any complexity to this process. And that's deceiving because the implementation actually has to deal with whether there are splats due to how the compiler interacts with the abstract syntax tree produced by the parser. But it looks like the net result, at least, does not result in any change in instructions. Now, in addition to splats, Ruby also supports nested multiple assignment to any level of nesting. So what differences do we see when the first assignment is changed to a nested assignment with the addition of a local variable? So this adds 2 instructions in both Ruby 3.0 and Ruby 3.1. And the only other change in Ruby 3.1 is that that first top n needs an adjusted offset. And what about the case where the nested assignment comes in the second assignment instead of in the first assignment? Well, in that case, instead of the first top n offset needing to be changed, the next 2 top n instruction arguments need to be changed. So we're going to consider one final case, where the results of the multiple assignment are not needed. Now, the Ruby compiler has many optimizations that take into account whether the result of an expression will be used or not. In this case, since the result of the multiple assignment is not used, Ruby should not create an array for the right-hand side of the expression. So on the Ruby 3.0 side, the new array, dupe, and expand array instructions are replaced with a simple swap instruction, so that D is at the top of the stack instead of E being at the top of the stack. And at the very end, a put nil instruction is used so that the leave instruction will return nil instead of an array. As you would expect, on Ruby 3.1, this also causes the offsets to change. It removes the need for the set n instruction, since that was only used to set the return value of the multiple assignment. Now, one thing to notice about the Ruby 3.1 instructions is, compared to the Ruby 3.0 instructions, is that even when the result of the multiple assignment is not used, Ruby 3.1 will still create an unnecessary array, while Ruby 3.0 will not. Now, I did not realize this issue when fixing multiple assignment. However, after I discovered it while developing this presentation, I implemented the same optimization used in Ruby 3.0, along with some additional optimizations that apply not just to multiple assignments, but to other cases where this and similar combinations of instructions are used. So those optimizations have been committed and will be in Ruby 3.2. All right, so from trying each of these small changes to multiple assignment and seeing how the instructions are affected, we can sort of piece together what affects these offsets. Well, we saw that the total number of assignments affects the offsets. We saw that the types of assignments, such as how many are local variables and how many are attributes, that affects the offsets. We saw that the order of assignments, like which ones are local variables and which ones are attributes, that affects the offsets. We saw that the number of element assignment method arguments, that affects the offsets. And we saw that the use of nesting affects the offsets. And we saw that whether or not the assignment expression return value is needed affects the offsets. So all those things must be considered when determining the offsets to use for the top n and set n instructions. even if you have all of that information, Ruby's compilation process actually makes using the information challenging. So you start the compilation process using source code. This is the Ruby source code that you write. And Ruby uses a parser, which turns your source code into an abstract syntax tree, also called a parse tree. So this abstract syntax tree contains nodes. You can use the dump option with Ruby with the value of p for parse tree, and Ruby will show you the parse tree for your code. So let's take the Ruby code example we've been using, and let's see the parse tree for it. This is the output, though I have simplified it quite a bit. In general, Ruby's compiler takes the parse tree as input and it outputs virtual machine instructions. And now generating the instructions in this case is quite challenging. In general, the compiler recursively processes the parse tree to generate the appropriate instructions. So this is the part of the parse tree related to the first tribute assignment. However, at the point that the compiler is processing this part of the parse tree, it does not have the information necessary to produce the correct instructions, because the offsets to the top-end instructions are not even known until after the entire multiple assignment node has been processed. So to work around this issue, the multiple assignment instruction compiler keeps 4 separate instruction sequences. So one is for evaluating method calls in the left-hand side. One is for evaluating the right-hand side. One is for calling the assignment methods, and one is for cleaning up the stack. While processing the left-hand side of the assignment, the compiler creates a linked list of structs containing the information for each of the top-end instructions. Each struct includes a pointer for where to add that top-end instruction once you figure out what offset it should be used, as well as that information needed to calculate the top-end offset argument. So after processing all of the nodes in the multiple assignment, the compiler iterates over this linked list, it calculates the correct offset argument to use for each of the top-end instructions, and then it inserts the top-end instructions in the appropriate places in the instruction sequences. After inserting the top-end instructions, the compiler merges the 4 separate instruction sequences into a single instruction sequence, and if the return value of the multiple assignment is needed, it adds the setEdit instruction to make sure that the assignment expression returns the right-hand side of the assignment. So far, we have only discussed multiple assignment. But as I mentioned earlier, constant assignment did not follow the left-to-right evaluation principle in older versions of Ruby. So we'll consider the following simple constant assignment example with the related instructions. Now we can see in Ruby 3.1 that C is evaluated before A, violating the left-to-right evaluation principle. While in Ruby 3.2, A is evaluated before C, following the left-to-right evaluation principle. Now, just as in the multiple assignment case, Ruby 3.2 requires more stack management instructions. However, for single constant assignment, you don't need to keep track of any offsets. Now, Ruby supports setting constants during multiple assignment. Hopefully, you don't see code that uses this. You can even set constants to splat values in nested multiple assignment. I would only recommend this if you really dislike the future maintainer, though. Now, changing the evaluation order for single constant assignment actually broke compilation of multiple assignment or constant assignment inside multiple assignment. So I had to update the compilation of multiple assignment to support left-to-right evaluation for constant assignment. As you would expect in Ruby 3.2, multiple assignments to constants follows the left-to-right evaluation principle, evaluating A and then D and then C, and then setting the B constant on A and the E constant on D. Now here are the lessons I learned related to these bug fixes. First, just because a bug is old does not mean that it cannot be fixed. These assignment evaluation order bugs have both existed since multiple assignment and constant assignment were added to Ruby, and both were known for multiple years before I started work on them. Be aware that bugs usually only reach old age for a reason. Bugs that are easy to fix are often fixed quickly. The older a bug is, the more likely it is to be difficult to fix. Even if you expect a bug to be hard to fix, do not let that discourage you. In many cases, the bugs that are the most difficult to fix are the bugs that you will learn the most from fixing. See an old bug as an opportunity to rise to the occasion and expand your knowledge of Ruby. Ruby currently has over 75 open bugs in the bug tracker that are over 5 years old, just waiting for you to fix. We look forward to your contributions. I hope you had fun learning about how we fixed assignment evaluation order in Ruby 3.1 and 3.2. If you enjoyed a copy of this presentation, you want to read more of my thoughts on Ruby programming, please consider picking up a copy of Polished Ruby Programming. And that concludes my presentation. I'd like to thank all of you for listening to me. A special thank you to CookPad for sponsoring my travel to RubyKaigi. I think I'm out of time, so if you have any questions, please ask me during the break. Arigatou gozaimasu.